Hi, this is Mrs. Doris. This is lesson 8-5, factoring x squared plus bx plus c. One thing that you should probably realize is we will, in the next lesson, be factoring trinomials of the form ax squared plus bx plus c. But the ones that we are going to do today, a is equal to 1. And so we don't have to show the a. All right, here we go. Understanding why this works, we're going to consider the product of the binomials x plus 5 times the quantity x plus 6. Now, you know that if we FOIL this, we multiply the two first terms together, which gives us x squared. We multiply the outer terms. X times 6 would give us 6x. We multiply the inner terms. 5 times x is 5x. And we multiply the last terms. 5 times 6 is 30. All right, and then we combine these two middle terms, the outer and the inner term, to get 11x. All right, so what we want to do is we're going to do the opposite of what we've been doing. We're going to start with the product and determine the two factors. So what we want to notice is that the 11 right here is made up of the 5 plus the 6. In other words, when we FOIL it, we get 11 by taking the 6 plus the 5. And our last term is the product of the last two terms, 5 and 6. All right, so here are some things that you should notice. The coefficient of x squared is 1. The coefficient of the x term is 11, which is the sum of the 5 and the 6 in the binomials. All right, so in the binomials, here's the 5 and here's the 6. The constant term, 30, is the product of the very same numbers. In other words, 5 times 6 gives you 30. So, looking at the last bullet, to factor the trinomial x squared plus bx plus c, then, you have to find two numbers that have, this should be a sum of b, our b in this case was the 11, and a product. In other words, you multiply them together in order to get c. All right, so let's take a look. Problem 1, factoring x squared plus bx plus c. What is the factored form of r squared plus 11r plus 24? All right, so first we want to find the factors of 24. All right, and so we can list those together. 1 times 24 will give you 24. 2 times 12 gives you 24. 3 times 8 gives you 24. And 4 times 6 gives you 24. Step 2 is to find the pair that have a sum of 11. Okay, because we want to get 11 in the middle. Well, we can do this in our heads. Looking at the first pair, if we took 1 plus 24, we'd get 25. 2 plus 12 is 14. 3 plus 8 would give us 11. All right, so step 3 then is to draw two pairs of parentheses. All right, so in other words, we're going to form our binomials. Our first term is r squared, so we know that the first term in each binomial has to be an r. And then we fill in the blanks with the two factors. All right, so let me just draw it again. Because all of our signs are plus, we know that our signs are going to be plus here, and we can take our pair 3 and 8. 3 goes in one and 8 goes in the other. Now, you can always check your factoring by using FOIL or the smiling sun, whatever you prefer to call it, and recognize that your first term, r times r, is r squared. Your last term, r times 8, is 8r. Your middle term, or your inner term, is 3r. And your last term, 3 times 8, is 24. So, and double check to make sure that outer and inner term add up to the 11r that you had in your original problem. All right, let's do this again. We're going to factor x squared minus bx plus c. All right, so my suggestion is that you go ahead and draw your set of parentheses. Because our first term is y squared, we know the first term of each binomial has to be y. Now, we're looking for factors of positive 8 that have to add up to negative 6. So factors of 8 would be 2 and 4, 1 and 8. And what we notice, if we made the 2 negative and the 4 negative, then they would add up to give negative 6. So our factors would be minus 2 and minus 4. And again, you can FOIL this to make sure that you get the original trinomial. Now, the next question. Can you factor x squared minus x plus 2? All right, well, let's draw our parentheses, and we'll put our x as our first term because of the x squared. And we're looking for factors of 2 that add up to negative 1. All right, well, the only factors of 2 are 1 and 2. And we want to get negative 1 if we add them. Well, you might think, okay, so if we make the 2 negative, that would work. But here's the problem. Let me erase this so we can see it. In order to get a positive 2 at the end, both of our factors would have to be negative. And there are no numbers that we could multiply together that would give us a positive 2, but that would add up to give us a negative 1 in the middle. So this expression cannot be factored, and it is what we call a prime trinomial, meaning it cannot be factored. And if you have any question about this, please ask. We know that negative 1 times negative 2 would be positive 2, but when we add them up, negative 1 plus negative 2 is negative 3. And, whoops, negative 3. And we certainly don't have a negative 3 here in the middle. The only other two factors that will give us a positive 2 is a positive 2 times 1. And, of course, 2 plus 1 gives us a positive 3. So we don't have any factors that will work. All right, problem 3, factoring x squared plus bx minus c. All right, let's draw our parentheses. We know from our first term in the trinomial that the first term in each binomial is going to have to be an n, so that when we multiply them together, we get the n squared. Now, our last term is negative 36, and we're going to have to find two numbers that multiplied together will give us a negative 36. Well, from experience, we know that when you multiply two numbers together and you get a negative, one's got to be a plus and one has to be a minus. So let's make a list of factors of just plain old 36. We have 1 and 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. All right, now, are any of these going to add up to a positive 9? So we know that one of these has to be negative. And what we notice here, if we look at 3 and 12, the difference between those is 9. In fact, if I make my 3 negative, then negative 3 plus 12 would give us the positive 9 that we're looking for. So right here I have my two factors. The 12 would need to be positive, and the 3 is the negative, so they need to go in this order. Double check it by using FOIL. All right. You know that n times n is n squared. Your last term, positive 12 times negative 3 is the negative 36. And then your outer term, negative 3n, and your inner term, positive 12n, do add up to 9n in the middle. All right, let's do one more. Again, I'm going to draw my parentheses, and my first term will have to be a c because of the c squared. My last two terms in each binomial are going to have to multiply together to give me a negative 21. So once again, I know I'm going to have a positive and a negative to make sure that I get a negative number when I multiply them together. Well, this one is not too hard. 21 doesn't have that many factors. Just 1 times 21 and 3 times 7. And we want these factors to add up to give us a negative 4 in the middle. So I think you see there's a difference of 4 between 3 and 7. And if we just make the 7 negative, then 3 plus the negative 7 would give us that negative 4. So our factors 3 is positive and goes in this blank, and the minus 7, the 7 will go after the minus sign in the second one. So we have the quantity c plus 3 times the quantity c minus 7. All right, let's apply factoring trinomials to this rectangle. A rectangle's area is x squared minus x minus 72. What are possible dimensions of the rectangle? All right, and we're going to use factoring. So let's draw parentheses. One will represent the length and one the width. We know that we're going to have an x as our first term in each one. Now we want to multiply two numbers together so that we get a negative 72. So I know one will be a plus and one a minus. But they have to add up the outer and the inner term to give me the negative 1x in the middle. Well, this one may jump out at you as well. We know that 8 times 9 is 72. One of these is going to have to be negative, and we want them to add up to give us a negative 1. So 8 plus a negative 9 will give us a negative 1. So we're going to make the 9 the negative. All right, so we have x plus 8 and x minus 9, and this would be your answer. All right. Problem 5, factoring a trinomial with two variables. Okay, when you've got two variables, and in this case you've got an m and an n. To get the m squared, we know our first term is going to have to be m. To get the last term, we know that we're going to have a plus and a minus. And we see an n squared in this last term. So that also tells us that there's going to be an n in the second term of each of our binomials. So now we just have to find the coefficient of that n. So we're looking for factors of 27, specifically negative 27, that are going to add up to a positive 6. So, factors of 27. We have 1 times 27, 3 times 9, and we don't have to go any further when we do find the pair that works for us. What we see is that if 3 is negative and 9 is positive, negative 3 plus 9 would give us a positive 6, and that's what we want for our middle term. So the minus 3 is going to have to go here after the minus sign, and the plus 9 here. And again, you can use FOIL in order to show that this is true. In fact, let's go ahead and do that. All right. So we have m times m. Our first terms would give us m squared. Our outer term, m times negative 3n, would be a minus 3mn. Notice we generally put our variables in alphabetical order. Our inner term, positive 9n times m, would be a positive 9mn. And multiplying our last terms together, 9n times negative 3n would be a minus 27n squared. And then combining our outer and inner term, negative 3mn plus 9mn would be a positive 6mn minus 27n squared. And you can see that we get exactly what we started with. All right. There will be a worksheet that has some problems on it for you to do. If you have any questions, please see me in class. This is a very important lesson, and you want to make sure that you understand it.